Ever wonder how your phone's AI assistant answers billions of questions without slowing down? It's not magic. It's smart systems like semantic caching working behind the scenes. Let's break it down. Imagine a library where every time someone asks for a book, the librarian either grabs it from the shelf, a cached answer, or hunts for it in the archives, a fresh computation. The catch: if the shelf has the wrong book, the user gets confused. But if the librarian searches every time, it takes forever. How do you balance speed and accuracy? That's the core problem semantic caching solves. Traditional caching is like a library that only keeps exact matches. If someone asks, "What's AI?" and another asks, "What is machine learning?" the system treats them as separate even though they're related. Semantic caching changes that. It's like teaching the librarian to recognize that AI and machine learning are basically the same thing. But here's the twist. How do you decide what to keep on the shelf when space is limited? That's where the new CLCB-SC-LS algorithm shines. It's like a librarian who doesn't just memorize books, but also learns which ones are most likely to be needed. Here's how it works. 1. It balances two costs. Mismatch costs, using a cached answer that's almost right but not perfect. Serving costs, asking the AI for a fresh answer which is accurate but expensive. 2. It adapts in real time. Unlike old systems that need all the data up front, CLCB-SC-LS learns as it goes, like a librarian adjusting shelves based on daily trends. Think of it like a chef testing recipes. You don't want to stick to the same dish forever, too predictable, but you also can't switch ingredients every day, too costly. CLCB-SC-LS is the chef who tries new recipes cautiously, only swapping out old ones when there's clear evidence they're not working. The results? This system outperforms older methods by up to 11.75% in tests, and it does it smarter, using less cache switching, like fewer shelf rearrangements. Plus, it's mathematically proven to be efficient, even when the rules aren't clear. So why does this matter? It's not just about saving money. It's about making AI faster, smarter, and more accessible. Next time you chat with a bot, remember, systems like this are working hard to keep things smooth. Thanks for watching. Hit subscribe for more deep dives into the science behind the tech you use every day. Let's talk about a breakthrough that's making AI faster, smarter, and way more efficient, without burning through energy or money. Ever wonder how your favorite chatbot or search engine handles billions of requests instantly? The answer lies in clever algorithms working behind the scenes. Here's the problem. Large language models, LLMs, are powerful, but they're also energy hogs. Every query requires massive computations, which can slow things down and cost a fortune. Researchers are tackling this by creating systems that think like a human, remembering what's already been done and avoiding redundant work. Enter CLCB-SC, a super smart caching algorithm. Think of it like a personal assistant who never forgets. When you ask, "What's the capital of France?" it stores that answer. But here's the twist. It doesn't just memorize exact phrases. It understands the meaning. So if someone later asks, "What's the capital city of France?" CLCB-SC recognizes it's the same question and reuses the old answer. This cuts down on wasted processing power, like skipping a trip to the library when you already have the book on your shelf. But here's where it gets wild. In real-time tests, CLCB-SC crushed traditional methods. It improved performance by 11.75% over epsilon greedy, a common baseline, and with some tweaks, like adjusting cache size or query types, it zoomed ahead to 54% better results. That's like upgrading from a bicycle to a rocket ship. But wait, there's a catch. Frequent data swaps, like replacing old books with new ones in the library, can slow things down. That's where CLCB-SC-LS steps in. It's the low-maintenance version. By reducing cache swaps by 90.91% and cutting runtime by 85.4%, it's like hiring a super-efficient librarian who never trips over their own feet. And guess what? Its performance stays almost perfect, even with fewer swaps. So why does this matter? Imagine your AI assistant responding faster, your smart home using less power, or web searches loading in the blink of an eye. These algorithms are the unsung heroes making AI not just smart, but sustainable. The best part? This research shows that blending offline planning, like mapping out a route ahead of time, with online adjustments, like rerouting on the fly, could be the future of AI. It's all about balance, efficiency without sacrificing speed. Next time you chat with a bot or search the web, remember, behind that seamless experience is a world of math and innovation working overtime. Thanks for watching, stay curious, and we'll see you in the next video.